increasing and decreasing functions. To determine whether a function is increasing or decreasing, we have to study its first derivative. If the first derivative is less than 0, or in other words, the gradient of the tangent is negative, we say that the function is decreasing. If the gradient of the tangent is positive, as along this interval, or the first derivative is positive, we say it is increasing. In those instances where the first derivative is 0, especially at the turning points, we say that the function is stationary. Now let us quickly consider this function y is equal to f of x and point P. Between the interval b and a, if I take the tangent at any point between b and a, it will give me a positive gradient. Hence, to determine an interval where the function is increasing, all we have to do is basically find the first derivative and equate it to greater than 0 and solve for x. Likewise, if we have to determine an interval where the function is decreasing, like for instance in this case, point P is on the other side of this quadratic, of this parabola. In this case, the tangent will give me a negative gradient, right? And therefore f is decreasing. And to determine that, all we have to do is once again find the first derivative, equate it to less than 0 and solve for x, and we'll be done. Now let's look at this example. For the function y, f of x is equal to x squared minus 7x plus 10, find the values of x for which f of x increases. So the very first thing I would do is find the first derivative. I get 2x minus 7, applying the power rule here. And then for an increasing function, I have to equate f dash of x is greater than 0. In other words, I'm getting a positive gradient of the tangent. So replace the f dash of x by the expression 2x minus 7 is greater than 0. Solve for x. I end up getting x is greater than 3.5. And if I graph this function, you can see over here, everything to the right, the interval to the right of x is equal to 3.5 will continually give me a positive gradient. Therefore, the function is increasing for x is greater than 3.5. Now let's look at another example. For the function f of x is equal to x squared minus 10x plus 7, find the values of x for which f of x decreases when x increases. Once again, we find the first derivative. Again, I'm applying the power rule over here. I get 2x minus 10. For a function which is decreasing, I have to equate f dash of x less than 0. I replace f dash of x by the expression I got earlier on, which is 2x minus 10 is less than 0, and solve for x. I get x is less than 5, and it is evident in the graph over here. The interval to the left of x is equal to 5 will continually give me a negative gradient. If I take the tangent anywhere along this point, I'll get a negative gradient. Therefore, the function is decreasing.